හරි පටන් හරි මේ කරන්න ඇති ෆස්ට් ෆ්ලෝ එකකින් තියෙන්නේ අන්න එන්තල්පි තියෙනවා එහෙනම් ඇති නේද මොකෙස් හරි පළවෙනි ටික ලේසි ප්‍රශ්න නෑ 6 kilojoule of work is on a system it evolves 8 kg evolves means release හරි the observer is in the system so delta u equals delta w plus delta q work is done on the system means work is positive so it is 6 and මේකට ටැමිල් කට්ටියත් පොඩ්ඩක් අර රික්වෙස්ට් කරලා තිබ්බ උන්ට සිංහල තේරෙන්නේ නැහැ කියලා ඒක පොඩ්ඩක් ඉංග්‍රීසි දාන්න ගණන් ගන්න එපා හරි මේ delta q evolves mean release that means out of the system minus 8 kg then final answer minus 2 kg easy easy hari lazy hari second one 20 kilojoule of work is done on a system on the system again this equation work done so work is positive it evolves means release 10 final answer plus 10 kg kilojoules third one the gas is present in a container fitted with a movable piston 20 kilojoule heat is given to the gas with no change in temperature okay no change in temperature means delta u becomes 0 isothermal so they are asking if the external pressure is 10 to the power 5 pascal calculate the change in volume so we have to write this one 0 equals because isothermal and it gets 0 delta w can be written as minus p external times delta v so minus p external and delta v plus delta q heat is given means it is plus uh, they're asking about the change in temperature so no volume minus 10 to the power 5 pascal times delta v plus 20 all the terms should be applied in the SI units so I have to put 10 to the power 3 joules and it will be so delta v equals to cubic meters මොකක්ද වැරද්ද තිබුත් කියන්න මේ sound එක ඇහෙනවනේ can you hear me I think no problem okay fourth one an ideal gas is placed in a rigid closed container closed container means closed system in a closed system delta u is 0 the answer is 0 okay fifth one a system takes up 500 cal of heat and does 100 calorie of work what is the delta u of the process again this one delta sorry delta U equals delta W plus delta Q. System heat take up into the system plus 500 and does 100 calorie of work. This means he's doing work to the, I think it is for the external space, so it should be minus plus 400 kg. There's a problem, it doesn't exactly say where to the work is done, so I feel it is done outward, so it is minus. uh, for the sixth question I have a doubt there, so I leave it for the final part. I'm going direct to the seventh one. The work done in, please remove the urge. Urge means 10 to the power 7. I think you don't know it. Urge කියලා එකක් දන්නේ නැනේ. ඒකින්ද ඒක අයින් කරන්න. Urge කියන එක අයින් කළා දාන්න. හරි. The work done for the reversible expansion of 1 mole of an ideal gas from a volume of 10 liters to 20 liter at is, then work equals minus n for the reversible process nRT times ln V2 divides V1. Okay, we don't know about ln because ln is log to the base e. So we are dealing with the log base 10. So there is a option, you can convert ln base or log e base to log 10 by multiplying the ln term by 2.303. Okay, when you multiply by 2.30c, it will naturally become the log 10 base. So I'm going to make it 2.303 negative times sorry, 1 mole 1. R means 8.314. T equals to, so temperature is not given, but I mentioned the temperature should be 298. Take the standards, it's okay. And this becomes log 10 to the base. When you multiply by, it naturally becomes the log 10 to the base 20 divides 10. No need to convert the units because there's a ratio. So if you apply in liter, it's okay. Then maybe you are wondering why they have used calories. There's a one thing, when you convert into this joule, no, the universal gas constant R, it equals approximately to 2 in calories. We normally write the 8.314, I can't remember, in joules, no. So when you are writing it calories, it approximately to 2, so it is easy to calculate. That's why they are using calories. I will mention it later. So in this part we are dealing with joules, so we have to use 8.314 comes to, this is the final answer. I don't know what is the answer. This is how it comes. මෙහෙම තමයි එන්නේ. මෙතන no problem කියලා. ඇහෙනව නේද කියන එක? ස්ලෝද? ඉගින්ද? සවුන්ඩ් එක මදිද? ආපහු පොඩ්ඩක් සිංහලෙන් කියන්න. මේ මෙතන 2.303 ආවේ මේ මොකද්ද ln බේස් එක log 10 බේස් එකට ගන්න. හරි ඒතකොට log 10 බේස් එක නැද ln බේස් එක අපි දන්නේ නැහැ නේ. log 10 නම් දන්න. මේ log මේක නම් 0.3.1.1 නේ. හරි. දාලා මේ සිම්ප්ලිෆයි කරලා ගන්න කොහොම තමයි. රිවර්සිබල් ප්‍රොසෙස් හින්දා මේක දාන්න දෙනවා. -nRT times ln v2 divide v1 මේක ඔප්පු කර කර ඉන්න ඕනේ නෑ සාමාන්‍යයෙන් මොකද මේක ඩිරෙක්ට් රිසල්ට් එක. හරි. එතකොට ෆයිනල් ආන්සර් එක ඔන්න ඔහම තමයි එන්නේ මේ ෂේප් එක සිම්ප්ලිෆයි කරගන්න. මොකද හරි. next one. 2 liters of a gas is expanded against an external pressure of 2 atm up to 12 liter. Then calculate the work done in joules. So there is no mention of reversible, so you can use the normal equation. The expansion work. So work is negative P external times delta V. To get the value in joules, you have to apply those things in the SI units. So 1 atm, if I think 1 atm is approximately equal to the 10 to the power 5 Pascal, or sometimes the real value of this is 1.01325 times to the power 5 Pascal. But I think this is easy to use here. So 10 to the power 5 Pascal times delta V, 12 minus 2. No, yes. And this is in liters. So when you have to put it in the cubic meters, because it is the SI units, so you have to multiply the liter value by 10 to the power minus 3. Then you can get the cubic meter value. So I'm gonna multiply it by 10 to the power 3 to convert liters into cubic meters. So answer becomes I think it is 2 atm. No? 2 atm. No? So answer becomes 10 to the power 6, 2000 liters, sorry, joules. So okay. If they are asking in joules, you have to attribute all the values with SI units, okay? Unless you will get the wrong answer. Ninth one. 2 mole of an I think no problem ne. Question ne mahitanne. 2 mole of an ideal gas is expanded in reversible and isothermal process from 2.24 liters to 22.4 liters. Then find out the amount of work done for expansion in joules. Okay. Reversible process. Work is minus nRT ln v2 divide v1. So if you have a doubt, you have to prove this. It's okay, you can prove and write the answer. But I don't know. You had to answer from demonstrator or the professor regarding that. That I will ask it when I go to the university on Monday. I'm going there because I have work there, and I will ask and I'll tell you that if we have to prove that before applying this, according to my knowledge, this is the direct result. So no need to prove. Okay, let's see. 2 moles. Before that, we don't know about ln base. So first we have to convert this into log base. So first of all, I have to multiply the expression by 2.303. And the number of moles, 2. R becomes 8.314, and the temperature is at 300, and this is log. When you multiply by this, it becomes log 10 to the base V2, V2 22.4, the final one 2.4, and the ratio becomes 10. So minus 2.303 times 2 times 8.314 times 300 times log 10 to the base 10 equals 1. So multiply by 1, and the answer becomes minus 11,488.2852 joules. I think it is enough to use 2 decimal points. I think we can carry the calculators. So if you are taking calculators, it's okay to use any decimal points you like. Okay, give me 1 minute to refill the marker. The next question: 260 gram zinc react with HCl, and the reaction is given below. Then calculate the work done in okay, work, not a reversible process, the single arrow. The work is denoted by done. So done, we have put the positive part, no? P delta V, no? But we have to deal with number of moles. So instead of PV, we have to use the delta in RT. First of all, we have to find out what is delta N. Delta N is the difference of uh, moles of the reaction. It says zinc to HCl, zinc chloride, and H2. Zinc number of moles, it uses 260 grams. The molar mass is 65, so it becomes 4 moles. According to the stoichiometry, it says 1 to 2 means there is 8. Sorry, there are 8 moles. 1 to 1, 4 moles. 1 to 1, 4 moles. So delta N, uh, there are 4, 4, 8. It's okay. Sorry, we have to use the gaseous reactants. No? Sorry, I forgot. Delta Ng RT, the gaseous reactants, because the work done by this gas. So we have to use the gaseous reactants. So delta Ng equals, this is the gas, and there are no gases. This is solid, equals. So delta N is taken by the gaseous reactants of products minus the gaseous reactants of reactants of the reactant side. So there are 4 moles, and there are nothing or no gaseous reactants in the reactant. So it is 4. So you can put directly 4 times the temperature 298. It is not given, so you have to use the standards. It is 298 Kelvin. So the answer becomes 9,000.288. මෙලෝ තේරෙන්නේ නැද්ද? ඔයගොල්ලෝ නැහනේ. ඔයාලා ඉංග්‍රීසි තේරෙනවනේ. ඉංග්‍රීසි කියන්නේ මහා දෙයක් නෙමෙයි ඈ. එංගලන්තේ සුද්දුත් හිඟා ගන්න ඉංග්‍රීසි. හරිනේ. හරි. ඒතකොට මේ රියැක්ෂන් එකක් දුන්නොත් ඒතකොට ඒකේ වර්ක් එක ගැන අහුවොත් if they are asking about the work, you have to find the gaseous reactants delta Ng. So when you see the delta Ng, it means the difference of products and reactants of gas. Okay, so that's all for the 10th one. Going to for the 11th one. Okay, there may be some confusing questions at 40th, 50th, 60th, and 70th. It's okay. Let's find out. I think I mentioned the reason why they use calories because it is easy to calculate, but I guess we have the uh, joules, no? We have the joules. Okay. 2 liters of N2 is at 0 Celsius and 5 atm pressure. It is expanded isothermically. That means delta U is 0. If there is no change in temperature, there's no change in internal energy. The first thing you have to remember. 2 liters of N2 at, I will sketch something. 2 liters of N2 at 0 Celsius at 5 atm, and always I'm using atm as 10 to the power 5 Pascal. If they say the other value, you have to use that. If you are given a calculator, there is no problem. Expanded isothermically against an external pressure of 1 atm. 1 atm external pressure until the pressure of gas becomes 1. Inside also become 1 atm. Calculate the work in expansion in joules. Okay. There is no mention about the reversible, so you have to use, so you can use this one, delta V. But there's a problem, we don't know the uh, delta V because we don't know the final volume. So first thing you have to do is you have to find the final volume. For that we have to get some assumptions that this is ideal gas. When there's ideal gas, you may have noticed this one, the Boyle's rule. P1 V1 equals P2 V2. You know P1 here, you know V1 here, you know P2 here. You only have to find the V2. So let's get started with that. P1, pressure 1, guys, 5 atm. You don't need to convert into Pascal. This is because this is a ratio, so no need to convert. And this is 2 and P2 1, and we don't know about V2. So the V2 is done by 10 liters because we used always liters here. Okay, okay, then take it here. We have to conclude that this is an ideal gas. Okay, unless we can't use if N2 is an ideal gas. Okay, so P external, according to this is the final position. It says it is 1 atm. 1 atm is 1 times 10 to the power 5 Pascal, and delta V becomes, the final volume is 10 liters. Initial volume was 2 liters. 10 minus 2 times, and it becomes, there's liters, but we have to find the work in joule. So you have to convert this into cubic meters. So first you have to multiply it by minus 10 to the power minus 3, and this will become cubic meters. So the final answer is coming as 10 times. Okay, is I think 800 joules. So okay. අවුලක් නෑ නේද භාෂාව තේරෙනවා නේ කියන එක කොහොමද ඉංග්‍රීසි නේ තියෙන්නේ. සිංහල දැන් ඉතින් ටික ටික අමතක කරලා දාන්න සිංහල වැඩකුත් නෑ. ලංකාව වැඩකුත් නෑ. හරි. මම ලියාගෙන ගියා පිස්සෙක් වගේ මේ ඔයාලා ලියා ගන්න හම්බුනේත් නැද්ද දන්නේ නෑ. හරි මම I think it's okay. ප්‍රශ්න නෑ නේ. සවුන්ඩ් එක අඩු නම් කියන්න. mic එක හිටපු ගමන් එහාට පයින්නවා. think no problem so far. 12th one. At 300 Kelvin temperature, 1 mole of ideal gas expands from 1 liter to 10 liter. Then calculate change in internal energy. Okay. මේක මෙහෙම හිතන්නත් පුළුවන්. You can think because there is no temperature change given, so you can think this is a constant pressure. So under constant pressure, sorry, temperature, you can think due to 300 Kelvin always and constant pressure, that means an isothermal process. No change in temperature, delta U is 0. No problem, because they are not asking about the work, they're asking about the internal energy. So internal energy is 0 because there is no mention about the temperature change. So we have to assume that the temperature stays constant throughout the time. So delta U is 0. Okay, because it is isothermal. Isothermal. Alright. Next one. 1 mole of ideal gas is expanded at 400 Kelvin temperature from 10 liters to 100 liters reversibly. Then calculate the heat in joules. Okay. Heat. They're asking about the heat. Let's see. Not the work, but we know delta U equals delta W plus delta Q. So there is no mention about the temperature change. So we have assumed that it is under the constant temperature. So when there is a constant temperature, it is an isothermal process. So delta U becomes 0. And we know how the work comes. We don't know work in a vidya. Reversible. So you can use 0 equals nRT ln V2 divides V1 plus delta Q. So get the delta Q here. We don't know about ln log G base, so you have to multiply it by the negative mark is gone because this also becomes negative, 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 cancel. 2.303 times what is the mode? 1 8.314. T becomes 400, no? 400 log 10 to the base 100 to 10. So finally 100 initially 10. It again becomes log 10 to 10 equal 1. අර උත්තරේ වාගන්න. හරි තේරෙනවනේ ඒක අපිට අපෙන් අහන්නේ heat එක. But we know there is no temperature change mentioned. So we have to assume that this is under isothermal. When isothermal, the delta U is 0 in the system. Okay. I think it's clear so far. So it says at means 400 throughout the time. So that's another confirmation that you don't have to think about the delta U, it already 0. Okay, fine. Let's go with. Let's go ahead. 16 gram of O2 is expanded reversibly at 300 Kelvin temperature from 5 dm3 to 25 dm3. Then find out du, dh, w. Okay, there is again at 300 Kelvin. That and they haven't given the temperature change yet. So you have to think that the internal change, which means the du is zero at 300 K and it is constant. So delta u, sorry, du equals zero. And the dh also zero. Why? Because uh, then work figure reversibly nRT ln v2 divides v1. So we don't know about ln. We have to use logs. So 2.303 මේක මෙහෙම මෙහෙම එකක් කියලා දුන්නද මම දන්නේ නැහැ. සාමාන්‍ය සිම්ප්ලිෆයි කරන්න ගන්න එක ln කියන ටැල් එකේ ගහන්න පුළුවන්. ඉතින් ගහලා ගන්න කොහොමත් එකම උත්තරේ. හරි. Number of moles O2 16 gram. O2 is 32 gm mol minus and 0.5 8.314 times tt 300. I'm writing this part here, log 10 to the base 25 to 5. And it becomes 1, 5, 2.303 times 0.5, 8.314 times 300 times log 10 to the base 5. Log 10 to the base 5, I don't know what is the answer. You can use a calculator and find the final answer. That's it. So when you are going to calculate the delta U, so delta U, delta Q, sorry, du, dw, dq. This is already zero, and you know the answer from here for the sorry dw. Okay. And sorry, sorry, uh, delta U equals delta W plus delta Q. So not asking about the derivative. So work is here. If you think this is x, you can put x, and this is zero because if du zero, u is also zero, and delta u, you can get the exact value of the heat change by this equation once you find the answer for this. Okay, let's go ahead. Track up and lemon and then Tamil කට්ටියට සිංහල තේරෙන්නේ නැහැ. ඒක පොඩ්ඩක්. එහෙමයි කියලා මට සෙෂන් ඔක්කොම ඉංග්‍රීසි වලින් කරන්න බැහැ. ඒක කාටවත් කරන්න නැහැ. 10ක් 15ක් වෙනුවෙන් මේ ලැන්ග්වේජ් එක වෙනස්. මොකද ඒකේ හොඳ views තිබ්බා මේ over 100 තිබ්බ සමහර වීඩියෝස් වලට මේ. ඒකට මේක අපරාධනේ. මේ හැබැයි මේ question discussion එක ඉතින් ඔයාලට තේරෙනවා. මේ මොකක්ද කියන්නේ කියලා. ඒකට මෙතන no problem. මම හිතන්නේ you can understand. මොකද හදන විදිය තේරුණා නම් ඇති. Next one. At constant volume to raise the temperature of 5 mole O2. Okay, I'm sketching O2 5 mole. From 10 Kelvin to 20 Kelvin, how much heat is required while constant pressure? Molar heat capacity is 7. Again, CP is given 7 calories per Kelvin per mole. Okay. Okay. uh, at constant volume, they ask me about the constant volume. When we are considering about the constant volume, we have to think of the CV. Okay. When CV is coming, you know that CV is connected with U. Delta U equals CV dt. Can you remember? And when you have to find the U, you have to integrate T1 to T2 CV dt. And this equation comes for 1 mole. It comes for 1 mole. So first thing you have to find what is CV, because it is given at the beginning of the question at constant volume. Constant volume means it is asking about the CV, but we only know the CP. But we know a relationship, this one, CP minus CV equals R. Okay, or CP minus CV equals NR. This is for the whole system. And this one, the bar, somewhat with the bar, and N is not given. This is for 1 mole. You can use any of this. You can use any of this. I'm going to use the both, and I want to mention what is the difference of these two equations. But I saw only, you are not this one only. I didn't see this one. Once we use this one, it is easy. So if I use this one, you know this, Cp minus Nr equals Cv. Cp is 7, but I said this is used for the whole system. The whole system consists not 1 mole. It has 5 moles. So you have to multiply it by 5. And there is N means 5. R is, oh, there's a problem. Oh, there's a problem. Maybe you haven't completed this because the heat capacity were given in calories. So you have to convert the universal gas constant into the calories because it is in the joule. එක joule වලින් තියෙන එකකින්ද ඒක කැලරි වලට හරවන්න ඕනේ. මම කලින් කිව්වා සාමාන්‍යයෙන් 8.314 joule per Kelvin per mole කියන එක approximately equal වෙනවා 2 calories per Kelvin per mole. 8.314 equals to 2 in calories. When it is joules, you have to use 8.314, and when it comes for the calories, you have to use the 2. So here they are given the thing uh, in calories. So I have to take this as 2 because R is 8.314 in joules, but in the calories it is 2. And CV comes. And this is not for 1. We should multiply it also by 5. That's පහෙන් ගුණ කරන්න ඕනේ. මොකද මේක පාවිච්චි කරන්න පුළුවන් whole system, and whole system consists of 5 moles. 35 minus 10 equals 5 CV. 25 divides 5 equals CV. So CV equals 5. If you use that equation, but C bar P, C bar V equals R, C bar 7, CV, R is 2 in calories. Because they have used calories, so the CV again becomes 5. So when you use this one, please be sure this is not for 1 mole. This is for the whole system. So you have to consider all the moles. That is why I have multiplied all the terms by 5. Okay. If you use only n for the 5, the answer will be different. It will give you -3. it is not acceptable answer for this one. So you have to multiply each term by the number of moles of the whole system. So when you use this one, it is okay. It is for 1 mole. We don't the CV dot does not depends on number of moles. So you can use this one or this one. I think you had better to use this one because the note says this one. So then remember when you are using this, if they are for more than 1 moles, you have to multiply from that factor. Okay. The factor again guna karan dena. So we find out CV equals 5. So accordingly, CV is 5. So then uh, so per mole, per 1 mole, you know when the CV is applied. CV can again applied because it says at constant temperature. Constant temperature again near the sorry constant volume. නියත පරිමාව කියන එක ගත්තාම ඔයාලට CV ගෙන්ම තමයි යන්නේ. CV connected නේ, CV is connected with the GU. Sorry, U. So U comes the integration of I think the temperature differences are given. So the initial temperature is yeah, 10, 10 and this becomes 20 CV and DT. Okay, so CV is a constant and DT. So you have to integrate CV. The DT is like DX. You know the answer is X. So it is T applied 10 to 20 because it has limits, boundaries for the integration. So CV is 5. CV was 5 in calories. Don't. And T 20 minus 10. You know the answer is A minus B. This is A and this is B. A minus B. So it says 50 for 1 mole. Only for 1 mole. But you know there were 5 moles. So you have to multiply for 5 moles. 50 times 5, 250. Final answer is in calories because we did not use joules, used calories. Okay. Okay. This thing you can use in here also. You can use in here also. No problem. But we know this equation, and it comes for 1 mole, and there are 5 moles. So you have to multiply it by 5. අර පහෙන් ගුණ කරන් දෙනවා මොකද මේක දෙන්නේ එක මෝල් එකට එක මවුල් එකකට විතරයි. ඉතින් එහෙම කියලා ප්‍රශ්න නැහැ. ඔයාලට මේක ඇඩ්ජස්ට් කරගන්න පුළුවන්. ඔයා බුල ඉඳන් වෙන් තියාගන්න. ඒතකොට n එකත් එළියට එනවා. ප්‍රශ්නයක් නැහැ. ඕම එනවා. හරි. හරි. ඉස්සරහට දින එකට මම n දාලාම හදන්න ප්‍රශ්නයක් නැහැ. හරි. Okay. Next one. To raise the temperature of 1 mole gas from 400K to 500K, how much heat is required while Cp is given as 3 plus 1.2 times in the power minus 3 times capital T. Capital T is I think it's a parameter. So the situation getting worse. We have to do more math on this. Good luck. Okay. They're asking about to raise temperature of 1 mole of gas, how much heat is required while Cp. So they have given Cp uh, and you know Cp is interacted with what dH, no? Cp dt. So when you have to find H, you have to integrate Cp dt from T1 to T2. Final answer will get Cp times T2 minus T1. So you can directly use this. I could not. I forgot to use this product before directly because I had to remind you that it comes like this. So for this one, you can't directly use this because there is a parameter for the Cp. Cp says 3 plus 1.2 times 10 to the power minus 3 T. So T is also engaged in the temperature. So Cp has a parameter according to temperature. When there is a temperature change, Cp also changes. That is why they have given, I think, two temperatures. No, so this will be quite difficult, and I don't think this kind of question will be asked. මේ වගේ එකක් අහන්න නැති වෙයි කියලා හිතනයි but පුරුදු line එක හොඳයි. Okay, so Cp comes with the H. So you have to, when you have to find H, you have to integrate from 400 to 500 Cp dt. This is for 1 mole, and there are yes, there are only 1 mole, so no problem. N is 1. So if you put N, it's okay. It does not also okay because it says 1 mole. So Cp, what is Cp? Something with parameter 3 plus 1.2 times 10 to the power minus 3t and dt. So you know there is a addition, so you can separate. So 1 becomes 3 dt plus other becomes 1.2 times 10 to the power minus 3 t dt. And then you can take out the constants. I'm erasing this one. Okay, you can take the constants out. 3 times 400 to 500 dt plus 1 times 2 10 to the power minus 3. But you can't put the t away. You have to keep it here. You have to integrate here. And dt 400 to 500. So let's get with the answer. 3 times dt, when you integrate dt, it becomes t for 400 to 500. And this one 1.2 times 10 to the power minus 3. You can see that 1.2. T dt, like it like x dx. No, the power is 1. So the answer is x squared divided by 2. X n plus 1 divides n plus 1. You can remember with this integration. Everyone knows now that if you had done the math course and if you have done these things in A level, you already know this. So t squared divided by 2, 400 to 500. Clear? Okay. So 3 times I'm attributing the limit, upper limit minus lower limit. I'm taking this thing out of here, and it says 500 squared minus 400 squared. Clear? Okay. 300 plus 0.6 10 to the power minus 3, and 500 squared, you can use it 500 minus 400 times 500 plus 400, difference of 2 squares. Any problem? Question sorry. So the answer is 9,000. Yeah, 9,000. No, method 100, method 900, 900, 9,000. No, 90,000. 300 plus 0.6 times 90 means 6 times 9, 54. 354. So all the answers were given in the calories. So final answer will be calories. That is a good maths. The 70th one is also the same. ඒකත් ඒ විදිහමයි. බලන්න there is a parameter called t. So you will encounter this like integration in the math. Am I speeding? I think it's okay. Okay, let's move on to the 70th one. The final answer is 354 calories because the CP was given in the calories. If you want to take it to joule, you will have to multiply that because 1 calorie is equal to the 4.184 joules. So dividing by this number, no, multiply this number, you will get the value in joules if they ask. If there is no problem about the mark, and unless they will give the CP in joules, it's okay. Whatever they give, you have to do this integration and no problem with the final answer. 70th, sorry, 17th. Okay, to raise the temperature of 1 mole of gas from 400 500 Kelvin, how much heat is required while CP? Okay, again CP. So there's a parameter, so you can't directly use this product. Unless there is a parameter, it's okay to use this one. Okay, but there's a parameter, so you have to use integration. This also come by the integration. Okay, so no problem. Integration, but whatever you had better to integrate this one. So there is no mistake. මුකුත් කියන්න බෑ එහෙම කරොත්. Temperature 100 to 200, 100 to 200, and CP. Oh wait. No, it's okay. And it says there are two more, so you had better to put n here because the CP, this equation is given for one more. It says there are two more, so you had better to put simple n. Okay, CP dt. That's okay. So you know n is a constant, you can take it out. And before we are dealing with CP, let's write it. 2.4 times 10 to the power minus 3 t dt. Again a t part comes, but you can take this out from the integration. So n says 2 times 2.4 times 10 to the power minus 3, 100 to 200 t dt. So when you integrate the t dt part, it becomes t squared divided by 200 to 200. Okay, and it becomes I am taking the half here, and no problem, you can cut this off. And t squared 100, so 200 is squared minus 100 is squared. 200 is squared minus 100 is squared. 200 minus 100, 100, 200 plus 3,000, I guess. No, 30,000. Okay. What is the value? I think it is about 72. No. 22.4 times 3. 670 like that. I don't know. This is the method. You can try. I don't think this kind of question wouldn't be coming for the exam. This is because there are more maths. I took this from the Cambridge or Oxford. I can't remember exactly, or some or MIT course. So they are focusing more on mathematics. Okay, 80th one. Let's see. This is called a PV curve. You know, maybe you have dealt with that in the A levels at the thermodynamics. Okay, this is V naught. This is this part is for V naught. This arrow is missing, and it says P naught and what is 2 P naught? Okay. A, B, and C. They're asking uh, 1 mole of monoatomic gas shows the following changes. Find out the DU for C2A process. C2A process given here. No, say okay. First of all, we have to find out what kind of process are those. Okay, give me a minute. Okay, let's find out. Okay. So du, uh, du is converted with CVDT, no? CVDT. No need to put simple n before because it says 1 mole only. Uh, C2A, no? C2A process. The temperature is not given here, but you have to find the temperature difference for this process because it comes from the DT, no? DT එකෙන් එන්නේ. එතකොට මොකද කරන්නේ? ප්‍රශ්න නැහැ. I will take this point as T naught, and you have to find this temperature in the terms of T naught. If you take different term for this, කියන්නේ වෙන පදයක් පාවිච්චි කරොත් අමාරු වෙටෙනවා. ඒකින්ද මෙයාගෙම මෙයා හොයාගන්න වෙනවා. හරි ඒකට තමයි මොනවද තියෙන්නේ? ඒකට තමයි සාමාන්‍යයෙන් අර gas laws තියෙන්නේ. බලන්න මතකද combined gas laws. එතන මෙහෙම එකක්. P1 V1 divides T1, P2 V2 divides T2. If I take this stage as C and this one as A, this point says it has a 2 P naught of pressure and 4 V naught of volume. And this point says it has P naught of pressure and V naught of volume. And we know that these terms, and I take this temperature as T naught, and for the C it is 2 P naught and 4 V naught, and the temperature is T naught. It should be equal to P2 is P naught, V naught, and T1. Okay, and you have to find the T1 in the terms of T naught. Then it comes P naught, P naught, P naught, P naught. This is the multiple is 8. 8 T1 equals T naught. Okay, so I write this is as T8 T1 and this is T1. then it will be easy to attribute in the equation. Okay, I think you had better to use the product of this one. Okay, this CV process, CV process, uh, CV dt. So when you integrate, you will get CV times t t1 t2 minus t1. I'm using the direct product. So they're asking du. Okay, CV, the value is not given, so I have to use CV. Okay, only one mole here. T2, there's not given. They have not given the temperature, so I'm using something that which I was taken. Uh, the final temperature was T1, and the initial temperature was 81. No, sorry, C2A. C point had I took it as T1, no, and T2. Sorry, 81. T1 was at the bottom. The graph I drawn before. So whatever. මෙන්න මේ වගේ answer එකක් තමයි. මේක exact answer ගන්න නිකන්. I think data is not appropriate. They have to give more data, but when you but I did not see the PV curves in the note, but I don't know because I'm not coming for those lectures. And when I get to a note and I have some resources written by some reputed professors in the world who one professor is had won the Nobel Prize for physical chemistry, I think 5 or 6 years ago. So they are reputed resources. Not only that one, sometimes I using internet, not chat GPT. ඉන්ටර්නෙට් එකේ තියෙන රිසෝස් ඔක්කොම බලලා තමයි මේක කියන්නේ. හරි මේ ඒතොර PV curves කියන එක කේම්බ්‍රිජ් එක්සෑම් වල එහෙම ලෙසටම අහලා තියෙනවා. ඒතොර මේකේ අපිට නෑ කියන්න බෑ. ඒකයි PV curve එකක් තියෙන ප්‍රශ්නයක් පොඩ්ඩක් දැම්මේ. දැන් පුදුම වෙන්න එපා. හරිද? මාත් මේව දන්නේ නෑ. මේක ඔයාලට කියන්න කලින් මාත් ඉස්සෙල්ලා මේක ලියලා බලලා ඊට පස්සේ දන්නේ නැති ඒවා හොයලා මේක කරලා රිසෝසස් බලලා තමයි මේ ෆයිනල් ආන්සර්ස් ටිකට ආවේ. න පැක් වගේ ඇති බේක ජුට 9:30 බැලුවා එකපාරට මෝඩ් එක වගේ එල්ල චාටරෙන්න බෑ. මේ ඒතර ඔය ඔක්කොම කන්ෆර්ම් කරගෙන තමයි බැලුවේ. මේ අන්තිම දෙක තුන බලන්න බැරි වුණා. PV කර්ව් එක සමනේ මම තමයි. හරි. එන්නේ නැති වෙයි. ඉස්සරහට තියෙද්දා මේ ෆිසිකල් කෙමිස්ට්‍රි වල ඉස්සරහට තියෙද්දන්නේ එහෙම තිබ්බොත් ඉතින් ඔය හම්බෙයි. උරින් දැන් දැනගෙන ඉන්න එක ප්‍රශ්නයක් නැහැ. Now you know how to find the temperature at each point. You can use the combined gas law, Charles law, Boyle's law, anything. You will get the answer. Ah, 7 T1 PV. Correct, that's your name because they are not given. Last two questions. To raise the temperature of 2 mole gas from 100 Kelvin to 200 Kelvin, how much heat is required while CP? Okay. If CP is engaged, they ask in delta H. CP T2 minus T1. You can use the direct product. So okay, you know how it comes by integrating this one. Okay, so what is the number? This is for 1 mole. 1 mole. So there are 2 moles. So you have to multiply it n. N means 2. and the Cp is 20, and the temperature is 100. So answer is 4,000 joules. You can use this directly. If you have a doubt, if you have time, you can prove it by the integration. Okay, and this is also written as like this. Uh, NCP delta. This is also come by this integration because the difference between the initial and the final temperatures says the difference. That's why they have used the delta. Okay. Final one. Calculate the number of kilojoules of heat necessary to raise the temperature of 6 grams of aluminium from 35 to 55 molar heat capacity. Okay. Simple thing. You know this from the O levels. MC theta. No, NC theta. Yeah, MC theta. M. What are the moment? 60. You can't keep grams. You have to use kilograms. 24 theta. You have the absolute temperature difference. When the difference in Celsius, it is also equal to the difference in Celsius. Kelvin difference है का Celsius difference का समान है because they are linear scale. So it is 20. Okay, you can. I think it is a very tiny amount, like very tiny. Okay, that's all. No, I skipped one question because I had a doubt. At constant T and P, so sixth question. We are going back to the sixth question. Okay, I have to discuss this with you because I have some doubts. Okay, because you have more hands-on experiences in lecture more than me. I think I have attended to the lectures about for the whole semester. I think 6 or 7 times, and after March I did not come to faculty only for the lab. Uh, that's what it is. So we can discuss single question. You can English, no problem. At constant temperature and pressure, which one of the following statement is correct for the reaction? C. Carbon monoxide gas, half O2 gas, CO2 gas. Okay, this one. Uh, they ask about delta U and delta H. So I can write an equation delta H equals delta U plus P. No problem. Okay. PP delta V. According to this, delta first one delta H is independent. For the physical state of the reactants of the compound. Physical state එක මත රඳාපවතිනලු පච රඳාපවතිනවා. Physical state එක වෙනස් වෙද්දී delta H වෙනස් වෙනවා. That is completely incorrect. ඊළඟට තමයි ප්‍රශ්න තියෙන්නේ. They say the temperature is constant. So when there is not change in temperature, delta U becomes zero. Delta U becomes zero. To my knowledge, delta U becomes zero. And what about delta H? According to my knowledge, for this reaction, the delta H of formation was negative value. It was an exothermic reaction. To my knowledge, how can I remember? So, and to become it zero, and I know this is negative. So, to my knowledge, the delta H should be lower than delta U, but they have not given the delta H of formation and enthalpy change of the formation. So if we think that way, there is problem. But to my knowledge, when it says, because I can't uh, think more, I think B is correct, but I feel C is also correct. The, that problem here. So, what is the answer? Is you got? Can you tell me මොනවගේ උත්තරද ආවේ? If this is ideal gas, no, it's okay. You were also confused. ඔයගොල්ලන්ටත් case දෙක. So that's a problem. I think the question was regarding this equation. Uh, I feel B is correct because this is they have used E as the internal energy. Yeah? So I could not tell you E is the internal energy. Yeah? So I feel this is right, but it can be C also because I can't remember what is the delta H of formation. Mm, whatever. Let's see this later. I can't think about this because I'm tired very much today. Uh, Teaching all the day today, from morning to evening and from 9:30 to now. හරි ප්‍රශ්න නැහැ නේද? මේ